This is Group 1,
Randall Elkind,
Emily Maharis.
Harrison Riggett.
Our team manufactured a 2-chamber plate heat exchanger.
One connected cold water flows from the top left corner to the bottom right corner, and hot water flows from the bottom left corner to the upper right corner. The hot water flows in this front chamber, and the cold water flows in this rear chamber. The heat exchanger is made out of aluminum, silicone rubber, acrylic, and steel fasteners.
The heat transfer occurs over a 16,000th inch thick aluminum sheet, which is sandwiched between two silicon rubber gaskets that are 1/16th inch thick. These gaskets provide sealed paths for the hot and cold water flows. These gaskets are also then sandwiched between two 1/4 inch thick sheets of acrylic. The heat exchanger connects to the testing unit properly at both inlets and both outlets.
The tubing is made of polycarbonate, which is 1/2 inch outer diameter and 3/8 inch inner diameter. For additional compressive force, we manufactured acrylic clamps located at the 4 corners of the heat exchanger. These are secured to the heat exchanger using acrylic glue and fastened using bolts. Additionally, we used U-channel aluminum bars with acrylic inserts to provide further compressive force on the interior section of the gaskets. The heat exchanger mounts to the testing unit using a simple aluminum angle.
The aluminum sheet is 6 inches wide by 12 inches tall, and the acrylic front and back plates and silicone gaskets are 5.75 inches wide and 11.75 inches tall. All fasteners used are 1/4-20, and the inlet and outlet tubes protrude approximately 2 inches from the front acrylic plate. The aluminum sheet was manufactured using a drill press. All acrylic components and the silicone rubber gaskets were manufactured using a laser cutter. All 4 polycarbonate inlet and outlet tubes were cut on a bandsaw and held in place using superglue. Shown here is our heat exchanger running under the desired operating conditions.
The results from our first evaluation are as follows. Leakage occurred at the middle bolt on the right side of the heat exchanger as shown. This only happened outside of normal operating conditions for the flow rates. Additionally, the hot water leaks into the cold water flow path.
The team learned that additional measures are necessary for proper sealing. Metallic components will be integrated into the existing assembly to provide a more evenly distributed compression force. The team will be adding more chambers for additional exchanging of heat and to improve efficiency.